So we've seen how to back up and restore individual servers, but in this last slide deck, I'm going to talk about how to back up and restore, well, mostly restore after a disaster that affects the entire IT infrastructure, or a large portion of IT infrastructure. So you have many servers that have failed, or an entire location that's no longer online. It could be because that location doesn't have internet and it can't serve the other branches or something along those lines. So we're going to talk about how to configure clustering on a multi-site network, how to recover a multi-site failover cluster. So Hyper-V Replica is a feature that periodically replicates changes on a VM to a mirror VM hosted on another Hyper-V server entirely. So basically, it's going to work over a standard IP network. So if you have two sites, and really what you're going to do here is you're going to have Hyper-V running in two different sites, possibly a third site, which we'll talk about in a little bit, but you would have Hyper-V running in two different sites. The idea here is that you basically have an online data center with a whole bunch of virtual machines. And by the way, this works very elegantly with virtual machines, but not so much with the physical machines. But that kind of works out because I think most of our infrastructure now is pretty much moving towards virtualization. So it generally just makes a lot more sense to go with virtual machines than physical machines anyway for your actual services. But in any event, you would have Hyper-V running, maybe even clustered Hyper-Vs running at your primary site. And then at a backup site or a hot site somewhere else, you have Hyper-V running there as well. And what's going to happen is periodically Hyper-V, or I should say asynchronously, this is technically an asynchronous, meaning that when changes are made at the primary site, those changes are replicated to a Hyper-V instance on a backup site. And they just kind of sit there waiting, and they're not really doing anything. It's just asynchronously storing all these changes to the virtual machine over time, so that if a failure ever happens at the primary site, the secondary site, you could spin up that virtual machine in the last known state. So that's basically how it works. Let me just click forward here with the slide. So Hyper-V servers can be can be at the same site or at different sites. They don't necessarily have to be geographically distant, although that's usually best practice. You can also use compression to reduce the bandwidth, so it can compress the replication between the primary site and the secondary site. So Replica could be used for site-level disaster recovery if you maintain a hot backup site. So as long as you've got Hyper-V running at this other site, it will periodically back up to the other site so that you can recover or bring those machines online at the other site in the event of a failure at the first site. There's also other times that you would do a recovery as well, which I'll talk about here in just a few minutes. So before a VM can be replicated to the replica server, replication has to be configured in the VM settings. So to configure replication on the VM, you're going to follow the steps in the text. And from the source Hyper-V server, the replication actions you can perform on a replicated VM are going to be to pause replication, remove replication, and view replication health options. And you can also do a planned failover. So basically, a planned failover is when, let's say you have to do some work at the primary data center or the primary VM, and you need to take it down for a period of time. You could bring it down, and as long as you're doing a planned failover, you can basically say, I'm doing a planned failover, so let the secondary machine take over. So then it will take over, and it will now be the primary. You can do what you need to do on the first machine. And then when you're done, you can transfer back to the primary machine. And during that downtime, the secondary machine is storing all the information about the changes and replicating over to the primary. So in normal operating mode, you're replicating from primary to backup. But during failover, you're replicating from backup to primary. Then once the primary is ready to take over, it's now back online as the primary and replicating back to the backup, if that makes sense. So that's basically how you can do this. So with the Hyper-V Replica broker, it's used to configure Hyper-V Replica between failover cluster nodes. So you configure it by adding the Hyper-V Replica broker role in the failover cluster manager console. So you'll do this right from the failover cluster manager console for Hyper-V Replica. You're going to right-click the role in the FCM console and then click Replication Settings. So an extended replication is used to replicate a replica. So this would be a third copy. So you may want to have a third location from which to run the VM. It's sort of a backup of the backup. So this is the real disaster recovery, right? So this might be, and where I've seen this used is you might do a replica within the same data center, because that way you can do failover and things like that. It's sort of another option of doing clustering more or less. and then they'll use the extended replication for the actual disaster site for the DR copy somewhere else. I believe there's also a way to do this with Azure, where you can do Hyper-V backups into Azure so that you can spin up the machine in Azure as opposed to in your own data center somewhere. So essentially your hot site could be Azure or even a different cloud provider if there's a way to make that work, which I'm sure there's ways to extend your infrastructure to Amazon or Google or something like that, or even Rackspace or one of those services. All right. So configuring multi-site clustering. So one of the drawbacks of using Replica for multi-site fault tolerance is that there's some data loss between the source VMs being replicated and the replica VMs because it's asynchronous. There's going to be some there's going to be some degree of lag or some latency between a change being made on the primary VM and the secondary VM or the replica. So Hyper-V Replica provides fault tolerance only for the VMs, but not for the physical computers. For real-time failover for both the VMs and physical computers, a multi-site failover cluster is best. So multi-site failover cluster requirements are the same as for any other failover cluster. They have to have similar hardware in the cluster nodes at all sites. You have to be sure the network infrastructure supports the shared storage scheme that you're going to use, because you have to have shared storage between these different nodes. So the multi-site cluster node and quorum configuration, multi-site clusters work best if there's an even number of cluster nodes with a node and file share majority quorum configuration, which we've talked about in the previous unit. So file share should be in a neutral site, right? So here's our file share that's in a neutral site between our two locations. So we can do a site level clustering between these two locations. So to configure multi-site cluster network configuration, it's going to include multiple IP subnets most likely because they're going to be in different networks, these two different sites. So client computers must be able to discover network services on another subnet when a site failover occurs. And that would help with automatic failover, right? So when the secondary site on a completely different subnet is now live, and all the services switch over to the other site, there should be some way to automatically tell the clients to start using services on that side. So you should consider multi-site, multi-subnet Hyper-V clusters to do that. Another option is to configure the network with VLAN so that the cluster nodes on each site are in the same IP subnet. There are networking technologies now where you can have VLANs that span a WAN, so that things like MPLS, and other WAN technologies where you don't have to, where the routing, you don't have to use routers to move the traffic between these different subnets or between these. So that allows you to have one giant network. So data replication options. Windows doesn't have an automatic mechanism to replicate storage data from this shared storage location on one site to another. So you have to provide the replication somehow. You don't use distributed file system replication because it replicates data only when files are closed, which obviously isn't going to help us with VMs and so forth. So replication of data can be synchronous or asynchronous. But again, you have to provide some other mechanism to do that. As I've mentioned before, a lot of this clustering stuff that we talk about with Microsoft, there are other options to do this with third-party tools as well as appliances that can facilitate this. That makes a little bit more sense for many organizations. So I don't want you to think that you have to use these Microsoft services to do clustering. There are other options out there for sure. So heartbeat settings, the heartbeat is a signal sent between the cluster nodes to inform them that a node is up and running. This is how the primary node or the backup knows that the primary node is online. So usually what happens with a heartbeat is the primary node or the secondary node somehow are making sure that the primary is online. If the backup can't get confirmation that the primary is working, then it takes over because it assumes that the primary is offline at that point. So if a cluster node fails to send the heartbeat signal in a specified time, the node is considered unavailable. And you can configure the heartbeat settings to account for varying network speeds. You don't want something to assume that everything is down when it's really just because the network is, there's a little bit of latency there. So if 5 heartbeats in a row are missed, then failover to another cluster node occurs based on that time that you set. So to configure the heartbeat cluster, the heartbeat frequency rather for the clusters, you're going to use the PowerShell commandlet cluster, and you can set that heartbeat time. To do it for cluster nodes in a different subnet, you would use same subnet delay parameter to cross subnet delay. So to change the number of times the heartbeat can be missed before a failover occurs, that's also going to be using the cluster PowerShell commandlet. And that's it. So we've covered in this unit, I have covered how to do backups at the server level, how to do recoveries at the server level. We talked about different types of backups. There's the bare metal backup, which is just pretty much everything on that machine. There was also volume level, file level, and system state backups, which could back up settings about specific roles. Then I talked about how to recover all that stuff to make sure that you understand how to do recoveries and that you can test that. Then I talked about using Microsoft Azure to do backups. So Microsoft Azure only supports file level backups, so you can't do system state or the bare metal backup, but at least you can back up files that way. It's nice because it's out in the cloud and you don't have to maintain those backup copies. We didn't talk about how to recover those, but certainly that's I believe the textbook does talk about that a little bit. And then finally, I talked about multi-site clustering, which, as I kind of covered, is even the book is a little bit light on multi-site clustering because I think a lot of folks kind of believe that Microsoft doesn't handle that very elegantly in 2012 R2. There are other tools that you can use to do that as well, but the features are there, and you can certainly use them if you desire. So that's it. That's this unit, and that actually also concludes this course. Thank you for watching my videos.